All right, so we're doing section 4.1 today, ladies and gentlemen. So a vector is a quantity that has both direction and magnitude. Magnitude is just another name for size and is represented in the coordinate plane by an arrow drawn from one point to another. So I gave you the diagram that's straight from your textbook, ladies and gentlemen. So it says the diagram shows a vector. The initial point or starting point of the vector is P, and the terminal point or ending point is Q. The vector is named PQ and is read as vector PQ. So look, it looks like it's a ray or a line segment. This one looks like it's a line segment. And the horizontal component is how many units it takes to go from the terminal point from the initial point, to the terminal point. And the vertical component is going up to the terminal point. All right. So on the one that they gave you there, the vector is 5 and 3. And notice how it's got these little different kind of brackets, because remember, if it was regular brackets, it'd be a point. So on this one right here, example 1, name the vector and write its component. So on this one here, your vector is, again, here's our initial point. And here's our terminal point, Q. And we're going to call it vector PQ. Now again, I kind of question this because to me it looks like a ray. So it'll be interesting to see what your homework says, because every once in a while they use, and I think even in the example in the textbook they use it as a ray. All right, so on this one here, our horizontal component is -4. Our vertical component is 5. So now remember, what that means is I went over 1, 2, 3, 4. And then I went up 1, 2, 3, 4, 5. Okay, and remember I went left, right? So that's why it's negative. Then I went positive up to it. Okay, so our component form is -4 and 5. All right, a transformation is a function that moves, not movers, moves or changes a figure in some way to produce a new figure called an image. Another name for the original figure is a preimage. The points on the preimage are inputs of the transformation, and the points on the image are the outputs. So a translation moves every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the points P and Q on a plane figure along a vector AB to the point P prime, Q prime. So when I have that little asterisk up there, apostrophe, we call it primes. So that one of the following statements is true. So P prime is equal to Q prime, and P prime, the line segment, is parallel to the line segment Q prime, Q prime. All right. And then remember, they're also collinear, which means they lie on the same line. So let's go ahead and look at the example here. So the vertices of ABC are 0 and 3. B is 2 and 4, and C is 1 and 0. Translate triangle ABC using the vector -1, -2. So again, we're going to make our diagram. So our first one is 0, 3. There's our A. Our B is at 2 and 4. And our C is at 1 and 0. All right, so again, that's a triangle, so we're going to connect our points there. All right, and then it says we're using the vector -1, -2. So what that means here is we are going to go and we are going to move our A, our B, and our C. So that means we're going to go over 1 in the negative direction, and then we're going to go down 2. All right, and that's where our A prime point will be. So we're going to call that A prime. Okay, we're going to do the same thing with B. So if I go over 1 and I go down 2, I'm not drawing it each time because you can just count. So that'll be our B prime. And then our C prime, again, I'm going to go over 1, down 2. And there would be our new figure. Now, I was lucky enough, my iPad gives me different colors. I tell everybody every once in a while, if you're doing it on the same one, if you don't label the points, you can always dash one of them. So make the image or the pre-image dashed, and then make the other one solid. But the key is to remember to call it primes. So like A prime, B prime, C prime. Okay? So, and then here I'll go ahead and tell you what the points were. -1 and 1. B was at 1 and 2. And C was at, C prime was at 0 and -2. Okay? All right, you can also express a translation along a vector using a rule which has the notation XY. All right, the arrow means maps to, or I just say goes to. So XY goes to X plus A, Y plus B. So write a rule for the translation of A prime, triangle ABC to triangle A prime, B prime, C prime. So look at what we did here. I'll just use C here because it's the easiest one to show you. So I'm going to go to get from C to C prime. I'm going to go, 2 right? So that would be positive, and 1 down, which is negative. So we're going to move along the vector. To -1. So, and again, that means every point I'm going to be able to move over 2 and go down 1. All right, I'm going to be able to do that for A and B. I just showed you C because that one doesn't get everything in the way. So, a rule for the translation is our XY point goes to our new point. And again, I just told you we went 2 right, so we went +2. And then we went 1 down, so X minus 1. So it's X plus 2, Y minus 1. Okay. Example 4. Graph quadrilateral ABCD with vertices A at 1 and -2, B at 2 and 1, C at 4 and 1, and D at 4 and -2, and its image after the translation x minus 1, y plus 4. So what we're going to say here is let's go ahead and make our quadrilateral. So I'm going to go 1 and -2. So here's A, right? B is at 2 and 1. So over 2, up 1. There's B. C is at 4 and 1. 1, 2, 3, 4, and 1. And D is at 4 and -2. And again, connect the dots. All right. So you can always just go ahead and do each point and then plot those points. So we could say that A, 1 to -2 goes to, again, if I'm going to take 1 minus 1, and again, it's A prime, so we're going to say 1 minus 1 is 0, and we're going to say -2 plus 4 is 2. For B, our point was 2 and 1, so I'm going to do the same thing. B prime is 2 minus 1, or 1, and 1 plus 4, which is 5, and so on, and so on. So C will map to 3 and 5, and D, which is at 4 and -2, will map to D prime 3 and 2. And just go ahead and plot that. Again, if you're using the same one, well, you're doing it on the Big Ideas website, so it'll probably do it for you. Maybe it'll make it different colors. I guess we'll find out. We're both learning things here. So we're going to go at 0 and 2. We're going to go at 1 and 5. We're going to go to 3 and 5. And remember, label those. And then D is at 3 and 2. So sometimes it gets a little busy there. But again, connect those. And you don't have to tell me the points because we just put them off to the side. Okay? And then finally, our last problem. So when two or more transformations are combined to form a single transformation, the result is a composition of functions. They are rigid motions, which means they preserve the length and the angle measure. So if we look at the one up here, if I drew them a little more nicer, you would see that I could take my regular ABCD, and when I mapped it onto the other one, it would have the same angles and the lengths would stay the same. They're saying when you do it more than once, which is what a composition is, it'll still do the same thing. So we're going to take and we're going to graph RS, line segment RS with the endpoints, -8 and 5 and -6 and 8, and graph its image after the composition. So what I say, -8 and 5, 1, 2, 3, 4, 5. So there's my R. RS is at -6 and 8. And we'll have that one, and it's not my prime yet, sorry. All right, so now what I did is I just found a graph and I thought I had the right one, but again, I kind of want you to see what happens is, remember, so in the first translation there, it's going to tell us that R of -8 and 5 goes to, again, R prime, which will be -9 and 9, okay? Our S would go to negative 6 minus 1, which would be negative 7. And then 8 plus 4 would be 12. So if we think about it on that one there, and here's where I kind of realized I chose the wrong graph, is I would be going this way, negative 1, and then I would be going up 4. So our new R prime would be here. But since we're doing 2 of them, it just needs the last one. A lot of times until you get used to it, I would go ahead and make my R prime and S prime, all right, until you get more comfortable with it. But then the second translation is the one that we're kind of worried about. And that now takes our R prime, which was negative 9 and 9, and that one will go to negative 9 plus 4, which would be negative 5, and 9 minus 6 is 3, and our S prime our S prime would go from negative 7 to 12, and that'll map to or go to S double prime, negative 3 and 6. So if you think about it, I did okay here because my last ones will map onto there. So if I just take the points, negative 5 and 3, and negative 3 and 6, there's my R double prime, there's my S double prime, all right? And if you just think about it, if you moved it this way here, if you went from S double prime to S prime and R double prime to R, you would see that it would still be the same, all right? So there's our transformations. We're going to talk about a lot of movement like this chapter. So we'll be talking about reflections tomorrow. So thank you.